ऑल राइट, कहाँ पे हैं भाई सब लोग? कोई क्लास थी या कोई क्लास नहीं थी इसलिए लेट हैं? ओके। ऑल राइट, सो विल आज की डेट क्या है भाई? 10। सो today we'll take a complete detour. We are supposed to talk about RLHF, which is reinforcement learning from human feedback, but we'll first talk a little bit about reinforcement learning. So maybe I'll just write the title of the paper. So this is the title of the paper. You can of course find it online. This is by W. Bradley. So this is the paper we are going to talk about, and so essentially before we start doing any of RLHF from the perspective of LLMs like ChatGPT, we will first just talk about what is RLHF. I mean, okay, so let us start this. So we know what are MDPs. If you remember, we had written these equations in our AI course, right? So do I need to write them again? You remember those equations? So maybe it doesn't harm to do 10 minutes of that. So we had things like S, and then in this state S you could take a set of actions. Okay, so you could take a set of actions. Let's say by taking action A you reach here, and this is S comma A. So this was our Q state that we had seen before. And then from here let's say we end at state S prime. Okay. Now how did we write equations for these? We had simply said that V star S, so some optimal value at a state S is given by max A Q star S comma A. And then we had said that Q star S comma A is simply summation T S A S prime, right, summation over all S prime. Okay. So, this thing multiplied with R S A S prime plus gamma V star S prime. So, this whole thing, I mean, these two are being multiplied and then we sum over all S prime. Finally, we had right. So, this is what we have already done. So, what was V star S? Just trying to remind what we already know. So, what is V star S? So, you have a set of actions to take from which state? You have a set of actions to take from state S. Which one do you take as V star? So, which one maximizes? Whichever one so for whichever action this value is maximized, so Q star S comma A, you will have S comma A for this, you will have S prime comma, you will have S comma A prime for this one, and similarly you will have values for all these. Which one becomes V star? The one that is maximum of all this, right? And then how do you compute Q star SA? What was this whole thing? So, which equations are these, by the way? What was the name? Right, Bellman equations. And what are they modeling? Which problem do they solve? What do they model? So, they model Markov decision process, MDPs. Now, so you keep on iteratively doing it until you maximize your expected utility, which is V star S. Now, tell me, when we talk about reinforcement learning, so how is reinforcement learning different from MDPs? How is reinforcement learning different from MDPs? How is reinforcement learning different from MDPs? So, in MDPs, you know all these quantities, they are just given to you. In reinforcement learning, so in reinforcement learning, T and R, they are unknowns. Right? T and R are unknowns. What is T? What is T? Transition probability that you will end up in state S prime You start from S and when you take action A. So this models that probability. Now if you see this whole thing, so what is this whole thing giving me? This whole part, this Q star SA. So these T S A S prime and then you take summation over all S prime, what is this whole thing giving me? See, so what should sum to 1? Let's put it this way. What should sum to 1? How many of you did AI? कुछ तो जवाब दो भाई. I thought ये तो अपन but हल्का सा याद ही नहीं है. Okay, so right now all I care about is T and R are unknown. What is T? Transition probability, that when you start from S, you end up being S prime when you take action A. So it's a function of all these three things. So it's a function from S cross A cross S to R, right? Because it gives you a value in the end. Now what about this guy? What is that now? When you start from S, take action A, end up in state S prime, how much reward is awarded to you? Who awards the reward? Who awards the reward? What is system? Right. So now we come back to what is reinforcement learning. So what is reinforcement learning? So there is an environment, and there is a agent, right? So as all do, so environment, so agent basically interacts with the environment. Okay. Now agent takes some action and environment returns state comma reward. So remember our grid world example, what was agent in that case? So the agent was who was going through this grid. Now what were the actions available to me? So forward, okay, north, south, east, west, okay, these were the 4 actions available to me. So I am that agent right now. If I take an action, right, I have done my thing, whatever I was supposed to do. I have taken my action, now environment is supposed to decide where do I land up, right. Now before MDPs when we were doing, we said everything was deterministic, in the sense that I knew if I am taking forward, I am going to move forward only, right. In this case, what was the case? We had modeled it this way, that if I take north, if I take a way forward, with probability 0.8 I will go forward, with probability 0.1 I will go to left, with probability 0.1 I will go to right. This is how my environment is. So I have no control over there, okay, and there was 0 probability of going backwards, okay. Now this was my environment responding. So if I am an agent, if I take action forward, I have taken my action, now environment will decide whether I go to, so this is my grid world, I am here right now, I take forward. So with 0.8 probability, environment sends me to actually forward. With probability 0.1, I end up being here. With probability 0.1, I end up being here. I have no control over it. Under my control, what was under my control? To take action. So I took action, I took this action to go towards north, but I may end up being here. So what will be the state in that case? So environment sends me to this state. Let me call 1, 2, 3, 4, 5, 6, 7, 8, 9. So I start from state 5. I took an action that should have taken me to state 2, but I end up being in state 4, and so this is just how movement is happening. Now what about reward? What was reward now? Remember what was the job of reward? So let me draw that whole thing. No, not required. What was reward? Remember, we had a grid world. We started from a start state. Right. So, right. Where was I? Right. What is reward now? What was reward? Remember, I start from a start state. I take actions north, east, west, south, right? And assuming that right now there are no immediate rewards, there are only two kinds of rewards. What were they? So either you end up in a pit, basically game over, or you end up taking the reward. So for reward we said, so if you end up in the top right corner, we will give you reward of +1. If you end up in the pit, we will give you -1. So those were the rewards. So we were modeling it that there are no immediate rewards when you move around, there are no rewards. So basically you can take infinite steps, but your goal is to reach +1. Now if you start if you start putting rewards for every action, we had seen that policy too, that if your immediate, the reward for every step was 0.01. What was it? Do you remember that grid? Yes. Right? So that grid was something like this. We start from here. Here was the negative pit, here was the positive pit, here was so here we had a wall. Now remember when we had this 0.01 reward, we were going from here to where? From here our policy was telling us to go south, not left. Why not left? because with point, so if your policy is this, with 0.1 probability you can end up in that -1, you don't want that. But if you move in this direction, the probability is 0 that you will end up being here, right. So when you had very small immediate reward, which was 0.01, the path taken was actually this one, because this completely avoided this pit. Now when you increase that from 0.01 to 0.03, right, some things changed, but I still think the path was still this. But when you changed it to 0.1, this became the path, and when you changed it to 1, what happened? You would actually like to go into pit because moving around is too costly, right. So what was the, I think awards were -0.01, -0.03, -0.1, -0.4, right, not positive, because otherwise so you will keep on circling and keep on collecting more and more rewards. You don't have incentive to actually go to even this +1, right. So all these things were -1. Now in negative. So this is what we are doing. You are an agent, you interact with an environment, you take action in the environment, and once you have taken action, you have got no control. Environment returns you a state and a scalar. So reward is always scalar. There is a huge amount of literature in reinforcement learning on this. Does it have to be a scalar? Can it be a vector, and so on? It turns out one scalar value is sufficient to model this reward. You don't really need your rewards to be complicated. So this reward is scalar. State is what your state is. So you have a complete state of set of whole states. Okay. Now, how does this help in what we are doing? So the paper that I have cited, this paper is actually from 2008, and from what I could see through various literature search, this was probably the first paper that talked about, reinforcement learning through human feedback. So RLHF is not at all a new topic, just that LLMs have made it very famous. This part is clear. So this is relatively straightforward. We go forward. Now, so what RLHF does now? So this is that paper in my hand now. So this is your environment. Now this is your agent. This is where a human is sitting somewhere. Right. So how should we try to put arrows now? So what it says here is, who is going to still take action? Action is still taken by agent. So let us put this thing as action here. What else? Environment is still going to return me. See, always think of that grid world. We will not go to LLMs, how to apply this thing to LLMs today, right? Always think of grid world. So as an agent, you took some action. So things are out of your control now. You can't do anything. Environment is certainly going to return you to the next state, whatever it is, right? So state is going to come from the environment. I'll draw it later. But reward is not coming from environment. So this human, so earlier what we had here, you see, environment was giving me both state and reward. In this model, environment is going to give me the next state, but the reward is being given by the human being. Okay. So, environment interacts with human being. So, environment is basically going to tell human that this is what the step my agent has taken. Okay. So, some kind of display of what my agent did, then reward, and then here you have, so here you have a supervised now let me draw the whole thing. What is still missing? State. So, state and state. So, earlier we had agent is just going to interact with the environment. So, agent takes action, ball is in the environment's court now, whichever state it throws me in and whatever reward it throws to me. Okay. Now, in this case, agent still takes the action, environment still throws the agent into the next state, but human is also looking at what my agent is doing. Okay. So, human looks at what my agent is doing and human gives the reward now. Okay. Now, how can we relate it to what we are doing right now? LLMs. This is not the exact model that they propose in related to LLMs, but still we can still talk about this one. Yes. By the way, this is pre-deep learning era, paper was in 2008, deep learning was almost not there for all practical purposes, people were doing it, people were doing neural networks, but no deep learning as such the way we know it today. Now, so where do our LLMs fit in here? So, if not here, tell me in the whole schema where can I use RLHF? Remember in the last class, what was the takeaway of the last class, and how many of you have gone through the Stanford lecture I had sent you? Okay. So, what was the takeaway from that lecture? They complete everything in that one lecture, right, which is too much loaded I think, but what was the takeaway from that lecture? The takeaway from that lecture is that LLMs are very good at predicting next token, right? They are extremely good at that. But that this being good at this task alone does not make LLMs helpful for human beings, right? The output has to be human like. Remember, we had seen those kind of slides where they said if you ask this to LLM, so if you ask this kind of question, tell me whatever this question for 6-year-old kid, and how was it completing the next thing? एक भी जना देख के नहीं आया है. And his speed is also too fast, so you can't even do 1.25x. Right. So, takeaway of this lecture was LLM itself does not help. What was the other thing? Fine tuning itself does not help. Instruction fine tuning is much improved thing, but is not yet there where humans can start using it effectively. So, language modeling is not same as assisting users. So, if you give this prompt, explain the moon landing to a 6-year-old in a few sentences, the GPT-3 completes. So, GPT-3 completes it as explain the theory of gravity to a 6-year-old, explain the theory of relativity to a 6-year-old. So, this might have, so all this text might logically complete this one, but this is not what is helpful to a human being, right? Human being basically asks the question and you are supposed to tell me answer and start, so you are supposed to predict the next token such that they are answers to this prompt and not this kind of completion. They are language rich, they are grammatically correct, they make sense, but this is not what the human being was looking for. So, now you have human into picture. Explain the moon landing to a 6-year-old in few sentences, human a giant rocket ship blasted and blah 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 whatever. Okay. So, if you give this prompt just to GPT-3, it is not going to be very helpful, it is not going to give us a helpful answer. If you give this to a human being is going to give this. So, there is a big gap between what GPT-3 does and how it can become actually helpful to human beings. This is where this instruction fine tuning RLHF come into picture, and so I think we will go back to our things. So, instruction fine tuning was this, but we had done this in one of the earlier lectures. So, again we go back to what we were doing. Yes. So, where do our LLMs fit here? Agent, right? Agent, but what? LLMs are my agent, right? Right. So, that is the only thing left. Nice. Supervised learners. So, if LLMs, assuming LLMs fit here, what else do we want? See, I just want you to fit this diagram in the story, because this is not the exact diagram that they are doing in RLHF papers, but everything is derived from here. This was kind of the first paper that started talking about how to take human preferences that give rewards to agents. So, you have a supervised learner, that in our case is LLM. We still do not know what is this reward model. Okay. Environment, what is that now? So LLM generates something, I give it to environment, basically the human gets to look at that, human is going to give me reward on that. So this thing makes sense to me. What is this guy? See, this thing makes sense to me. LLM, I give it a prompt, it generates some text for me, I am done generating my text, I have no control over it now. This text goes to a human being has to figure out whether this was helpful or not, and based on that gives me a reward. This cycle is fine. What about this guy? Where does this fit in? Huh? See, this reward model. So this was pre-deep learning era. Now let me try to draw what is. So even though I asked you to look at the Stanford lecture, but what I found much more useful was this lecture by Hugging Face. So there they actually talk about this. In the Stanford one, they don't really go into the details of anything. So maybe that's a good idea. If so, maybe just refer to that properly. This one, okay, and
once everything's perfectly organized,
and if you go to the description, you can basically go to the slides that I am using now for this course. Okay, so all right, so now let me draw the next one, but this was already very helpful. So you have your language model, you train also a reward model. Why? So see, this agent, this is my LLM, but I am also going to implement a reward model. What? So see this internal, this arrow is fine with, so let us decode all these arrows. This arrow is fine with everyone. So I am an agent, I take an action, right? So for environment, this whole thing might be an agent, because what this LLM is doing inside, I don't really care. What text you give me is important to me. So agent has taken action. Based on whatever agent has given me, I show it to a human being. Human being gives the agent a reward back. This cycle is very much fine. Now environment is going to give me a state, right? That is also fine. What is problematic is here. We'll fix those things. It's not word by word, it's like prompt. You give a prompt, LLM is going to complete something, and then LLM is done. Okay? But what is going on here? So there is a reward model. What this reward model might do? Here you are trying to predict. See, you are a supervised learner, you do weight update, you try to basically devise a reward model that I need to mimic this behavior. I need to predict in advance what is human being going to give me. So if I produce a piece of text, I need to predict it in advance how much reward is a human going to give me. So in which case can you remove this human being from here in this diagram now? When can you remove this human being? Right. So when your model is good enough that it is able to match the reward from human being. Once your reward model has become so efficient that it has modeled this reward from human being really well, then you don't need human labelers. Now this information I did not have before. So basically OpenAI employed a lot of human beings to do this, and they actually spent millions just to create this data set where human beings are actually annotating the data set. So there was a prompt, LLM gave me some answer, what did human give me? So I'll go into those details now. I mean, I don't have that much time to do that today, and I don't even want to do that today. So OpenAI actually invested a lot of money into this, and that's why they have ChatGPT. Okay. So not this one. I was supposed to do something else here as well. Tell me. So what might be this state here that environment is giving me? What is y hat? So y hat is in this guy's hand. What is environment going to give me is, and what is that? So see, I gave a prompt, this guy gave me a completion, this guy gave me a reward. What is still left? I need to compare my output with the actual one. Okay. So this model does not fit LLM completely, that's why we are going to change it now. It is what it is, but just with a small change. It is still, I mean, okay, let me take my words back, it is still fine. So you did something, you generated a text, environment is going to give me, see, this is what we were looking for. So what you generated versus maybe what was the actual answer, and then human is going to give you a reward. With these two comparisons, you are going to train a separate reward model that is going to tell me how much reward do I expect when I am going to generate something right now. So when I am generating a response to a prompt right now, what is the reward am I expecting? If this is high enough from whatever I have learnt, if I am able to match human reward, I am okay with it, else I need to keep on updating my reward model. This is again a machine learning model where what will be the input and what will be the output. Okay, that's a good question. So what will be the input and output to this reward model? You can see everything here now. So my output as a LLM, what else? My output as a LLM and what was the response of a human being on this. These two are fed to me. Based on that, I try to predict a reward. What is reward that I am trying to predict? So what kind of neural network will it look like? By the way, if I remember it right, this model itself was a 6 billion parameter model for InstructGPT. I mean, InstructGPT, it is rumored to have, it is rumored that ChatGPT is nothing but InstructGPT. I mean, its evolved version, they changed the name. So InstructGPT paper was in March 2022, and in November 2022 they released ChatGPT. and that is also now one of the reasons why OpenAI's, I mean, of course, they might have their own secret sauce that nobody knows, but the kind of RLHF that ChatGPT has received from, a lot of human beings, because within 5 days their number of users was 1 million, and this did not happen for any other chatbot. So the kind of interaction that OpenAI's chatbot has had with human beings, and assuming that RLHF is still damn necessary, right? ChatGPT or GPT-4 or OpenAI models are much ahead compared to others. But there are research lines that say you may or may not need this RLHF. So again, but that's a research line. So I think this, my goal was to talk about this figure completely today. Is that fine? Yes. Which one? These two? Right. So LLM is going to give me something, that is its prediction, but I need to tell LLM, see, this is what I was expecting, kind of, because there are human annotators that are telling me that. Okay. So one thing could be, so this thing alone does not capture that somehow fully, right? Ideally it should, because you see, if you just tell me LLM gives me a piece of text, I just tell it that I am going to give you a reward from 0 to 1, or say -1 to 1. Okay. If you give me a really bad output which is abusive and so on, I am going to give you -1. If it is okay, I will give you, let us say, 0. And so basically a linear, a real number between -1 to 1. If it is good answer, what I expected, I am going to give you something close to 1. Ideally this captures, right? But you want to train this thing as well, because, so ideally if you want to train just on the value of this, it becomes a bit difficult. Here this is a so this is not my LLM. This guy receives input from my LLM as well as what the original input a human being had written there, the original output that human being had written to that prompt. You give me that, I try to predict a reward based on these two input, and I basically try to model what human being, how is human being giving me the reward. Okay. This is that same thing. No, this LLM is not generating. If LLM was generating, the arrow would be this way. So I give my LLM, see, this is the right answer. So GPT-3 must tune its weight. I am giving those things here, so my reward model must tune its weights, and so on. Okay. More questions here. I don't want to draw the next diagram now. So let me see if there is something important. So one more thing, in reinforcement learning, what do you exactly optimize? Remember what was the tagline for our AI course? Maximize your expected utility. So there is no notion of discount here in this case, right? Because what you do is you care about, you want to actually model the immediate reward. So I don't want to maximize, my expected utility over some period of time. I just care about what is my immediate reward. That is one difference. And there is, I mean, there are things that are so they say that in fact in animal learning literature, training by reinforcement learning is defined as rewarding successive approximations of the goal behavior In other words, as performance increases, the trainer's standard for what are good actions increase as well. So, earlier when GPT was giving me really bad answers, if you improve upon it, I am going to give you reward, but there is no limit to improvement. So, my reward function actually keeps on changing with the behavior. So, now once GPT starts giving me helpful results, so earlier baseline was GPT giving me whatever. After training, GPT improves, baseline becomes this. So, their baselines also keeps on changing depending on my current long term behavior of GPT. So, I think that is it for today's class. We'll probably finish it in the next class, but certainly we'll finish it in next 2 classes. Sorry? Human interaction with environment, right? Why do you think so? You mean the answers? See how, for example, I need to think about it. But this is not what we are actually using for LLMs. There is some other diagram, so maybe that will be able to help us. Why? Because this was not done in the context of LLMs. Okay? Because let's say, okay, that's it. Chalo, done for today.